Oh, all right.
Mhm.
We're on air.
Yeah.
So, Max Mountner here.
Ben Jacobson.
And we're on part 5 of making our way through MIT's Distributed Systems course, for those of you who are first joining us.
Yep.
Uh,
Raft consensus algorithms.
so, neither me or Ben do distributed systems necessarily for full-time jobs, but we're working through the problem sets of the course. And at this point, yeah, we're working on the Raft consensus algorithm, which is lab 2. We'll include links to the course website, which is where we're viewing the problem sets and whatnot, and also to our public GitHub repo, where we're pushing our code and our solutions to the labs. I'll go screen share so people can see.
Yep.
The other thing I'll do is I'll enable Keycaster, which lets people see the keystrokes that I'm using, as I am using Vim. So, whoa, what was that, dude?
I don't know.
Do you want to take a look real quick? That sounded horrific. Was that like trash or? Dude, it sounded like a
I don't
bomb.
know. The construction, they're building a building next door.
Oh my
Sounds like they
God,
dropped
dude.
the building.
That sounded like a fucking bomb. All right, let's get back to distributed systems.
Yeah.
That sounded horrific. Jesus.
All right. San Francisco's
Okay.
still here.
Good, good. So I'll make the font a little bit bigger. This is our GitHub repo, which is really the source code that the course provided us with. So all of our core code for the course is really in the source directory, of which there's a lot. But the Raft lab is the one we're working on. We're going to be going till 11 here, so we've got a couple hours. Where we left off was that we had the voting step. We were initiating the vote amongst servers in a cluster about who should be the new master or new leader. Let's get back to that lab 2A and see where refresh ourselves about what the problem was.
I think we were still working through the hints.
Oh yeah, we got through like 3 or 4 of them. Add any. All right, where do you think we left off?
I think
We filled in these request vote args and request vote reply structs.
yeah. Were we implementing heartbeats?
We were very close to that. I know this is the test file. In the RaftGo file is where we're making all our modifications, really. And at the bottom was this make function, which is where heartbeats and elections are maintained. But yeah, I think here was the send heartbeat commented out code that we started on.
Okay. I
think we were looking at the send request vote RPC. And the send request vote is a wrapper to make an RPC call of request vote. And request vote is what I think finished in the last live stream. So
yep.
This is determining which way should a node vote in an election.
Yep. Okay.
So I think, yeah, you're right. We're on to heartbeats. To implement heartbeats, define an append entries RPC struct. I think we already did that. Yeah, we did.
Okay.
And but you may not need all the arguments yet, and have a leader send them out periodically. Write an append entries RPC handler that resets the election timeout so that other servers don't step forward as leaders when one has already been elected.
Okay.
Okay, we have our append entries args and append entries struct, or append entries reply structs, but the append entries RPC handler is pretty unimplemented for sure.
Pretty unimplemented. Okay.
And
we created this method.
Yeah,
last time?
yeah, we did.
Okay.
In these enumerated behaviors, we copy pasted from the actual Raft paper,
Yep.
which was required reading for the class, but we didn't make it very far through.
Right.
Here we go. The extended Raft paper. Specifically, there's a figure in the paper on like page 3 or 4 here.
Yep.
So the append entries RPC here in the figure was what we were referencing. We literally copy pasted these receiver implementation.
Okay.
But yeah, when it came to that hint for part 2A of the lab, we filled these structs, and then we were supposed to modify make to create a background Go routine that will kick off leader election by sending out request vote RPCs.
Yep.
So I think before we do the append entries heartbeat RPC, we should figure out whether we're kicking off the election properly here in our make function. So to make this less ambiguous, make is past a list of peers and a server identifier, and it's which is a me integer. And so make is initializing our
Maybe I'm breaking up.
Oh, the audio wise?
Yeah.
Could
have been me.
Okay. I was just explaining what make does. It makes
Okay.
a Raft instance, an instance in a cluster of nodes that are following the Raft protocol for electing leaders and whatnot.
Yep.
So the kicking off of election is where we were like, what is going on?
Yeah. So we're sending vote requests at all of our peers, and now I think we need to collect the votes.
Yeah.
Or something like that. So
yeah, looping over all our peers, sending them a request vote RPC. And because it's a async RPC, we need to collect the results. So I don't remember how to collect those results. I think
maybe let's just try running the test. Yeah.
Yeah. I think I need to set my go path or go route. Getting a little bit further. That's not good. Maybe I need to unset go route and set go path. I'd assume that
set go path. I thought. Yeah, go path to the 6.824 directory.
Got it. Not into the source directory?
No.
Go root or go path?
Go path.
And should I unset go root maybe? Cool. All right, we're getting a little bit further. So line 304, missing length argument. Here we'd started making a list to collect the results. So it looks like we need to tell it how many, it's basically the length of our peers, right?
Yeah.
I think we're making an array as opposed to a slice. That doesn't look like the same syntax. I think we're making a slice here.
Yeah.
Is length global in?
I don't know. Maybe. I don't know. Let's give it a shot.
peers dot length.
Is that what the error was?
Oh, we have length peers here. Yeah, the error was you're not saying how long your array of votes is.
Okay.
Only 3 or 4. It doesn't like our expression. Maybe we need a space or something. I don't know what's going on there. Maybe we're just declaring a variable.
Yeah.
Okay, non-constant array bound. Number of peers. I guess this is
I don't
some
think
Golang specific stuff. Non-constant array bound number of peers.
Yeah.
Wow.
Let's go back to the documentation.
About declaring arrays?
Yeah. You'll see slices much more often than arrays in typical Go. Let's look at slices.
Yeah, for sure. That looks like the syntax we're going for. It looks like the second argument is the number of.
Yeah.
So let's actually, I don't think we've stopped to read about this, so it might be worth reading about.
Yeah, unlike arrays, slices are typed only by elements they contain, not the number of elements. To create an empty slice with non-zero length, use built-in make. Here we make a slice of strings of length 3, initially 0 valued. We can set and just get like with arrays.
Okay.
Okay.
Cool.
Length returns here. Length. Yeah. Yeah, sounds like we should just use slices all the time.
For our purposes, yeah, it probably doesn't matter. We can do, as before, we're doing make this slice of bools, and maybe now it won't mind that we have a non-constant length. Oh, so that error message did go away.
Excellent.
Now lines 320 and 321, reply.term is undefined.
Yeah, so
it needs to be capitalized.
Yep.
There was a hint for people who weren't here last week. There was a hint about with RPCs, which is something that these labs make heavy use of. When you're passing around a struct data type between RPCs, like we're doing, it's important that you capitalize your keys in the struct, or else they're treated as private and not visible, I guess, or aren't changed, or
yeah, they're not sent over the wire or something.
Got it. So these 4 lines are kind of questionable. I remember we added them right at the end last week because we were trying to increment our term.
Yeah, current term.
So we were trying to like set the term for our election kicker offer equal to the max of our peers.
Yep.
So that we're all caught up about what is the current term. But let's try running the test and see what happens. Votes declared and not used. Oh, we're not even using it. We can comment it out for now. So cool. We're running the tests. We're seeing the logs. They should fail or run infinitely. Looks like one of the tests failed up here.
Yeah.
So no one's being elected leader yet.
Right.
Okay. I'm going to check real quick in the lab about how to run the tests only specifically for 2A. Looks like this is the way to do it.
Yep.
A good way to debug your code is to insert print statements when a peer sends or receives a message and click the output on the file. By studying the traces of messages in the out file, you can identify where your implementation deviates. dprintf. Okay, let's try running just our 2A tests.
Yep.
Where previously we were running all the tests. This will take a couple. This will take like a few.
Okay.
basically both tests are failing.
Because no leaders are elected.
Yeah. So from the lab where we left off, you were mentioning that we hadn't implemented heartbeats yet?
Yeah, well, that's just the next hint.
Okay.
Okay. Hmm. Yeah, maybe we should just try to finish the election process.
Yeah, agreed. So collecting the votes was the first thing.
Yeah.
So once we've called the RPC to request a vote of a peer, to collect and set the given index to being the reply object.
Yeah, or the reply dot vote granted, maybe.
So the RPC or the struct request vote reply has a term and vote granted.
Yep.
That's true false, like you said. So we can, let's print it.
Mm-hmm.
%R, is that right? Something like that?
Yeah, something like that. V for value, maybe?
Value?
I don't know. Let's give it a shot.
Yeah, that's good. We don't have a new line, but yeah. So we're seeing that we're getting back all these true votes, but then we're not acting on it yet.
Yep. And so we have there's 3 peers, right?
There are three peers, including ourselves.
Including ourselves.
So one of these trues is the leader voting for themselves.
Okay.
Or the person who initiated the vote voting for themselves. So if, I mean, this is a simple if statement. If majority of votes are true,
yep.
In the same way we initialized is leader to be false, and convert is leader to be true. And then immediately after that, we'd probably want to set a heartbeat, send a heartbeat, which is what we'll be doing next. To notify all of the peers that we are the new leader.
Yep. Maybe let's just try setting this to true. No, that's not gonna work.
Yeah, I think this is being ran by all peers at this point.
Yeah. Okay.
Since no one is becoming the leader fast enough.
Yep.
So how do we do?
So maybe majority of votes, instead of trying to figure out with an array of bools, maybe we just create 2 counts. Count positive votes, count negative vote, and then if positive votes is greater than the negative votes, we're the leader.
Okay. I mean, should we do that in a for loop? I'm pretty ignorant of any list or slice.
Yeah, I don't know the slice helpers. In Ruby, it would just be like .any or .select.
Yeah. If votes I. This is seriously.
Yeah. Let's give it a shot. What's it complaining about now? Might need to be in parens here. No. You might need to wrap your for loop with parens.
I copy pasted it from up here.
Oh, maybe not. Okay.
Yeah, it clearly doesn't like something. Expected statement found else.
Line 335.
Wow.
How do you do an else statement in Go?
Yeah, seriously. I don't know. This looks good. I don't think it cares about white space here, like if it's on the same line or not. Maybe it doesn't like the
Maybe plus equals
increment.
isn't yeah.
Nah. What the H?
338.
Oh, 338. That's where we're at. We have a closing curly brace.
Oh, if majority of votes are true.
Oh. Wow. If yes, greater than no, yeah. Cool. All right. There we go.
All right.
All right. So now we're successfully voting, or a leader is being set to true.
All the tests are going to pass.
Oh, yeah. All the tests are going to pass. Oh, they didn't pass?
Oh, no.
So, yeah, all of our peers are becoming leaders in the first term of the election. So we need some way for the first leader to go. Oh, we had it right here in pseudocode. Yeah, to broadcast to the peers that we are the leader now.
Yep.
All right, this looks like all pseudocode, so that's why we're getting these errors. So yeah, besides setting ourselves to be the leader, looping over our peers again, we're not going to send a heartbeat to ourselves. Now, sending a heartbeat, according to the paper, is just sending an append entries RPC with no new entries.
Yep.
So our args are going to be the append entries arg struct, and the append entries reply structs. So we have above an example of how to declare those pretty easily, like this.
Mm-hmm.
However, the struct looks different. We've got term, leader ID, previous log index, entries, and leader commit.
It said we might not need all of them, so.
Okay.
At least initially.
We can send the current term. So.
Yep.
We don't need either of these. Leader ID is ourselves. And then previous log index. That is the index of log entry immediately preceding new ones. For now, we can hardcode that to 0, let's say.
Yep.
Entries should be an array of log entries. But for us, we're going to have an array of like 0.
Yep.
And for now, we can hardcode the leader commit to be 0.
Yeah, and you need colons after those keys.
Good call. Oh, and then the append, missing comma. Expected type found comma on line 349.
349.
There we go.
Okay.
Still, it expects expected expression. So maybe we need to make a list of length 0 or whatever, or a slice of length 0.
Yep.
I think append entry args though is declaring it needs to be a list as opposed to a slice. So we can say it's a list of length 0. Is that right?
Yeah.
Call it empty entries. Still having an expression problem.
Line 345.
Oh, that's not valid, I guess.
That's not valid, yeah.
So what was our way to declare an array right there?
Well, let's try that without the equals.
Good idea. Okay, it made the error go away in the bottom.
Okay.
Line 355. We're not declaring any of these. So just term int. Yeah. RF.current term. Or these can be null, I think.
Yeah. Do we need to declare the reply?
You're right, yeah. It's just an empty struct. Nothing's defined yet. Oh. Oh.
All right.
So now we're sending this heartbeat RPC. We defined the send append entries wrapper, I think.
But we haven't implemented append entries.
Yeah. Okay. We're getting kind of far. Yeah.
Yeah. Maybe.
Maybe.
It's hard to tell if we're making progress, but.
Reply false if our Raft term is less than the current term. So rf.term, since we're dealing with ourselves, a Raft instance.
Yep.
If rf term less than args.current term.
Okay.
Now you return false. Let's see whether I got that right. Current term.
No. Term is on the args. Current term is on ourselves, I think.
Yeah, you're right. So I think we define the Raft instance attributes here. Yeah. When we're making a Raft instance.
Yeah.
We initialize all these values, current term being one of them. So getting back to our append entries RPC here, we're just returning false to append entries if we're not caught up to the current term.
Yeah, we have to swap those.
We got to swap args.term less than current term.
It should be args.term is less than or equal to.
Yeah. Less than or equal to?
Or sorry, less than.
And reply false if log doesn't contain an entry at previous log index whose term matches previous log term. So previous log term, I think, is also in append entries args.
Yeah. Previous log index. Did we miss a term?
Yeah, we did. Oops.
I'm not sure what those are used for quite yet.
I think it said that this is basically the one node telling another what was the last thing they wrote to their logs or have a record of being written to their logs. And so the previous log term is probably the last term in which a log was written that they have observed.
Okay.
So that's something we'll need to keep track of in the well, is that maybe that's an attribute of an entry, a log entry? Yeah, it is. A log entry has the command and then the term.
Okay.
So we should be able to see in our append entry RPC.
Yep.
If our logs accessing a previous log index, there's going to be all kinds of key errors here in the event that we'll encounter that in the tests. If previous logs log index term doesn't exist,
or is no.
is nil or doesn't equal the one that we expect it to equal.
Okay. Equals nil. And then or double bars instead of or.
Oh, good call. Yeah. So this is probably wrong.
Yeah. Let's give it a shot.
Okay. Need some kind of like try catch or something like that. Handle the case where that previous log index, which is coming from args. Same thing over here. And therefore, it's capital previous log index. Okay. If an existing entry conflicts with a new one, same index but different terms, delete the existing entry and all that follow it. Whew. Okay. So we have our logs stored on our given Raft instance that's receiving the RPC.
Okay.
Woo. Okay. So if rf.logs args, well, append entries, the append entries args takes a list of logs entries that can be written. So we need to loop over length of args.logs.
Log entries? What do we call it? Logs, yeah.
So it's called logs on the Raft instance, but this
called entries.
Entries, yeah. I think we used entries because that's what's called in the paper.
Yeah.
Okay, so we loop over all the entries.
Yeah.
Oh,
I mean, at this point, they're not logs; they are entries. I guess. I don't know.
Yeah. And so we're just checking if they're in the logs, in the Raft instances logs.
Okay.
So the logs are this array of finite length, and I don't think the entries that we're passing into the RPC have any indication of their index in the logs. And rather, the way to figure out a given entry's index in the logs is to look at the previous log index.
Okay.
So when we call it append entries RPC, and we're sending from our leader to our followers a list of new log entries to add to their logs, the way these followers are figuring out where in their logs to write these things is based off of the previous log index.
Okay.
So,
okay.
Oh my God. Log entries don't have an index, I don't think.
I don't think log entries has a term.
It's just command and term. I think that was given to us.
Yeah.
Oof.
Okay. Let's see a log entry struct.
Yeah, we wrote one, but it doesn't have an index.
Okay.
So actually writing new entries to the logs looks like we need to invoke another RPC. Or maybe not an RPC, but there's this channel that the tests expect us to write to when any given one of our Raft instances are writing a new log entry.
Okay. So
I don't think we need to worry about it yet.
Yeah. Log entries are committed. The peer should send apply message to the service on the same server via the apply channel. Okay.
So
I don't think that's necessary for this part.
yeah, we're still involved in elections.
Yeah, yeah.
In fact, the only reason we're writing the append entries stuff right now is because we need to make sure that our follower instances do not try to run an election again, or call themselves leader. So we can come back to steps 3 and 4 of the behavior of append entries.
Yep.
It looks like it's missing some steps relating to figuring out or setting ourselves as not leader or whatever.
Yeah, how does it know not to set? Oh, no. It should work.
What's that?
Well, I'm just trying to understand how this algorithm works.
Okay. Should we pull up the paper? Or?
Yeah.
So it's not a super long paper.
Yeah.
I'm trying to see how many pages it is. 18 pages with citations, so 17. We can come back to performance, but the heartbeat stuff was where we were leaving off.
Yeah. So let's go back to the code, I guess.
Okay.
So args.term, so the first check that we're doing where we return false there, the first node that runs this, that gets initialized, is going to think it's the leader. It's going to start the election. Is the term that sends, is that incremented before the election starts or after the election starts?
When not when calling send append entries, but when calling request vote.
Yeah. That's just the current term. Oh, and the current term is incremented.
We are sending
okay.
our current term +1.
Yeah. Okay. Yeah. Yeah, I don't see anywhere in there where it's setting the like.
Where by sending a heartbeat or any kind of append entries, the followers are...
Yeah, the followers don't start the election process.
The one thing we were supposed to do or bake in is how often should a given node kick off an election?
Maybe we need to do that.
Yeah. To prevent ourselves from prevent the nodes from calling election all the time.
Yeah.
So this here is a infinite for loop.
Yep.
We're sleeping at the end here for 1 second.
Yeah. Yeah, I guess let's try to do that. That's the only way I see that the election's going to stop after the first node is elected. Okay.
So should we do this timestamp based check or?
Yeah, I think that works.
So this last heard from any peer timestamp is something that I think we made at the end of the lab working last week.
So that's not part of the paper, is it? It's not explicitly part of the.
Yeah, it's not. Yeah, there's no keeping track of timestamps. Here's this very generic rules for SIRS section.
Okay.
If RPC request or response contains term T greater than current term, set current term equal to T and convert to follower. That's pretty important.
Oh, that sounds critical.
We have that right here. If we get back a term in our election that's greater than ours, then we round ourselves up, but we don't set ourselves to is leader equal false.
Okay.
So is leader equals false is being a follower.
Yeah. I mean,
Yeah.
maybe that's all we were missing.
All right, let's give it a shot. Oh God.
Oh.
225, yeah. So it doesn't take any response value. Oh, we need to specify what type of response value there is.
So is it return false, or are we supposed to return, update the reply? What is the reply supposed to equal?
Yeah, you're totally right. It's a struct term and success.
Yeah, okay.
So rather than having any return value,
yep,
just need to modify, reply dot success.
Yep.
And then down at the bottom here, we'll have a fallback value if true or whatever.
Yeah, I think you're going to need to do returns after those successes.
Oh yeah, so it aborts.
Yep. And then we also need to set the term.
Yeah.
So I'm guessing current term.
Maybe this is a similar case where we need to say is leader equals false, and also set the current term equal to. Oh, this is if the. Sorry, never mind.
Yeah, I don't know.
This is if we get a request to write to our logs from a leader, quote unquote, who's behind us in terms of being aware of the current term. So I think we're good.
Yeah, but the reply still needs a term, I think. I think we just set the term that we reply with as our current term.
Okay, so reply dot term equals.
That's kind of what we did in the other one, but I'm not 100% sure.
Well, the other thing it's complaining about is rf.logs is undefined.
Okay.
I'm pretty sure down here. Ooh, it's an arbitrarily long slice, or I believe.
Okay.
Let's see if we get an error about that. Oh God, so many problems.
Okay. Logs is part of our struct, right?
It is, yes. I'll jump back up to the top there and see, but log singular.
Okay.
Should we do log or logs?
What does the paper say?
Log.
Log. All right, let's do log.
Okay, cool. This is undefined. Type log entry has no field or method term, but does have term. Oh, okay. Another case problem. Here. Cannot convert nil to type int.
Okay.
We need to. There's a different way to check whether Golang integer is nil.
Actually, that should never be nil, right? That index, that whole thing could be nil, but term should always be set.
I think you're right, yeah. So we should nuke this part of the bool statement.
Yeah, so we could add that back in, but instead of doing dot term equals nil, it's just the object at that index equals nil. I think that's possible.
Or what if we just do length of rf dot, or yeah. If the length of rf.log greater than args.PreviousLog index, we're basically we're checking whether the length of our log is long enough to contain.
Yeah, so less than, right?
Less than. Or no, we're just checking whether we already have this log index set.
Oh, if we already have it set.
And
yeah, okay.
And the log entry we have set is for a different term.
Okay. Yep. I think that makes sense.
Reply false if log doesn't contain an entry at previous log index whose term matches previous log term. So if it does not contain so is it replying false if we don't have? What the H?
Reply false.
Here's where we pulled this from, is the receiver implementation of append entries RPC. Reply false if log doesn't contain an entry at previous log index whose term matches previous log term. So that sounds like an and type of statement.
Reply false if log doesn't contain an entry previous log index whose term matches previous log term.
We can go look at section 5.3 of this paper. That'd probably be where it's at. Once a leader has been elected, it begins servicing client requests. Each client request contains a command to be executed by the replicated state machines. The leader appends that command to its log as a new entry, then issues append entries RPCs in parallel to each of the other servers to replicate the entry. When the entry has been safely replicated, the leader applies the entry to a state machine and returns the result of that execution to the client. If the follower crashes or runs slowly, or if network packets are lost, leader retries append entries RPCs indefinitely. Okay, logs are organized, blah, blah, blah. Each log entry stores a state machine command along with the term number when the entry was received by the leader. The term numbers in log entries are used to detect inconsistencies between logs and to ensure some of the properties in figure 3. Each log entry also has an integer index identifying its position in the log. The leader decides when it is safe to apply a log entry to the state machines. Such an entry is called committed. Raft guarantees that committed entries are durable and will eventually be executed by all of the available state machines. A log entry is committed once the leader that created the entry is replicated on a majority of the servers. For example, figure 6, whatever.
Entry 7 and figure 6.
Figure 6 is up here.
Entry 7. Oh, entry 7 is on a majority of the nodes.
Mm-hmm.
Okay.
The leader keeps track of the highest index it knows to be committed, and it includes that index in future append entries RPCs, including heartbeats, so that the other servers eventually find out. Once the follower learns that a log entry is committed, it applies the entry to its local state machine in log order.
Okay. We designed the Raft log mechanism to maintain a high level of coherency between the logs on different servers. Not only does this simplify the system's behavior and make it more predictable, but it is an important component of ensuring safety. Raft maintains the following properties, which together constitute the log matching property in Figure 3. If two entries in different logs have the same index and term, then they store the same command. If two entries in different logs have the same index and term, then the logs are identical in all preceding entries. Okay. Okay.
This is not mind-blowing yet.
Yeah.
What we were trying to figure out is here. In Raft, the leader handles inconsistencies by forcing the follower's logs to duplicate its own. This means that conflicting entries in followers' logs will be overwritten with entries from the leader's log. Section 5.4 will show that it's safe to do this when coupled with another restriction. To bring a follower's log into consistency with its own, the leader must find the latest log entry where the two logs agree. Delete any entries in the follower's log after that point, and send the follower all of the leader's entries after that point. All of these actions happen in response to a consistency check performed by entries RPC. So we're writing the consistency check right now, I believe. The leader maintains a next index for each follower, which is the index of the next log entry. The leader will send to that follower. When a leader first comes to power, it initializes all next index values to the index just after the last one in its log.
Okay.
The follower's log is inconsistent with the leader's. The append entries consistency check will fail on the append entries in the next append entries RPC.
Okay.
Oof, dude, this is heavy duty.
Yeah.
Basically here, the consistency check in append entries, reply false if log doesn't contain an entry at previous log index whose term matches previous log term. So if we have enough log entries that we think we are caught up with the leader, and its term isn't equal to the term the leader thinks it is, then we reply false.
Yep.
Okay. Now, if an existing entry, we're kind of getting ahead of ourselves because we haven't actually finished the election part of this.
Yeah, I don't know if any of this is required for the election piece.
Well, I think the reason we did it was because when it came to leader elections, as soon as a node becomes leader, it sends out the heartbeat RPC to notify its peers that it's leader.
Yep. And how much of that RPC do we need to write to satisfy the leader election portion?
Yeah, not much, I don't think. Although it didn't look like there were any aspects of append entries RPC, at least the instructions here, that suggest that upon receiving a heartbeat RPC, that a node should change its behavior around the elections.
Right.
The section of the paper immediately previous to this is about leader elections, or section 5.2. So we could read that. It's maybe less than one full page.
Okay.
Raft uses a heartbeat mechanism to trigger leader election. When servers start up, they begin as followers. A server remains in follower state as long as it receives valid RPCs from a leader or candidate. Leaders send periodic heartbeats, append entry RPCs that carry no log entries, to all followers in order to maintain their authority. If a follower receives no communication over a period of time, called the election timeout, then it assumes there is no viable leader, and begins the election to choose new leader. That was why we added that if statement in our make loop. If last heard from any peer in more than a certain amount of time, then kick off an election.
Yep.
So we're not setting this anywhere, so we don't have that set up yet. To begin an election, a follower increments its current term, which is here.
Yep.
And transitions to candidate state. Okay. Not sure what that means.
Okay.
It then votes for itself and issues request vote RPCs in parallel to each of the other servers in the cluster.
Okay.
A candidate continues in the state until one of three things happen. A, it wins the election. B, another server establishes itself as leader. Or C, a period of time goes by with no winner. These outcomes are discussed separately. Okay. I think for passing our first two tests of part 2A of the lab,
Yeah.
I don't think we have to cover a lot of this ground.
Right.
Probably.
Right.
A candidate wins an election if it receives votes from a majority of the servers in the full cluster for the same term. Each server will vote for at most one candidate in a given term on a first-come, first-served basis. Note, Section 5.4 adds an additional restriction. Okay. The majority rule ensures that at most one candidate can win the election for a particular term. Election safety property, figure 3. Once a candidate wins an election, it becomes leader. It then sends heartbeat messages to all of the other servers to establish its authority and prevent new elections. While waiting for votes, a candidate may receive an append entries RPC from another server claiming to be leader. If the leader's term included in its RPC is at least as large as the candidate's current term, then the candidate recognizes the leader as legitimate and returns to follower state. If the term in the RPC is smaller than the candidate's current term, then the candidate rejects the RPC and continues in candidate state. Okay, that makes sense.
Yep. I guess, yes. So my question is, in the append entries RPC, we return a response, but are we supposed to update our state at all?
This is suggesting that it depends. Or what we just read suggests that I think we need to keep track of whether our Raft instance or node is in candidate state. Okay. And one of the things we have to handle in our append entries RPC is if we're in a candidate state, is currently a candidate, and the terms are different. Or sorry, and the terms are the same.
Okay.
So if our current term is the same as args.term, then we need to say we are not the leader anymore. We need to, well, give up our bid at becoming leader.
Okay.
Does that make sense?
Yeah, I think so. It's just not, it's not spelled out.
Yeah, we kind of shot ourselves in the foot by copy pasting this and assuming this was the end all be all, I think.
Yeah. Existing code.
So append entries does more than just write things to the log. It also checks whether the message being sent, the append entries RPC being sent, is coming from a legitimate leader.
Yeah. Okay.
We were reading about the heartbeat just a moment ago, and while waiting for votes, a candidate may receive an append entries RPC from another server claiming to be leader. If the leader's term included in its RPC is at least as large as the candidate's current term, then the candidate recognizes the leader as legitimate and returns to follower state. If the term in the RPC is smaller than the candidate's current term, then the candidate rejects the RPC and continues in candidate state.
Yep.
So do you think we need to make a is currently candidate or is leader, whether it's a candidate or not?
Well, I think that piece of logic is handled in our first if statement there.
In our first append entries if statement?
Yeah. If the term is less than the current term. I think that's doing what
Got it.
it's describing.
But if it's greater than or equal to, if the provided term is greater than or equal to,
Yeah.
then we need to cede control, you know?
Yeah. Yeah. But then we need to reply false as well.
That we failed to get it?
Yeah.
Or write the.
Yeah. See, but that case is not covered in the figure. So that's why I'm wondering if this like state update is happening somewhere else.
Let's fix some of the Go compilation errors we're getting. I think that'll get us closer to being back on track.
Okay.
We're missing the length argument to line 318. Say length 0 for now, yeah.
Okay.
Cannot use empty entries. That's a law. That's type law. Line 376. What is it not like about our empty entries?
Let's use make down here as well.
Okay. I think it's going to complain with a type error. Oh, I guess not. Line 380. Oh, I think similar to how up here we use ampersand to dereference our structs.
Yep.
We're not doing that down here. Okay. So this append entries thing is suggesting that all of our nodes think they're the leader and they're trying to send their logs to everyone else.
Okay.
So our tests are still failing, and you can see the votes are coming back true. We can make these debugger statements a lot more.
Yep.
Verbose votes collected by rf.me. We can say.
We could also put a sleep in the RPC call.
Which one? The election one?
The election one or the append entries one?
Okay. Where do you think would be good?
Just at the bottom of our append entries. Yeah, right under reply.success equals true.
Right here?
Yeah.
For how long do you think?
I don't know. Let's try. Yeah, let's try that. Yeah.
Guess we can't.
We won't. Yeah, that's fine.
Okay. Well, our tests are feeling faster.
Okay.
So it looks like all three nodes are kicking off an election.
Okay.
And then all three are getting votes back from the first node.
Okay.
They're coming back true.
Okay.
The vote collecting is continuing. And it looks like the first node gets back all their votes first. So he thinks he won the election. But little does he know there's other elections going on.
Right. Okay.
And so the third node gets back all of its votes and thinks it won. So it declares that it has won the election.
Mm-hmm.
And so it looks like the first node is sending its heartbeat to the second node.
Yep.
And it looks like still the second node is running its election.
Okay.
And is collected a vote. And the third node, who also thinks it's won the election, is sending its heartbeat to the first node.
Okay.
And so voting is still going on and heartbeats are still being sent, but yeah, two of these guys think they're the leaders. In fact, 3 should think they're the leaders because
right.
we got 3. 1 won the election, 2 won the election,
0 1.
0 won the election. So
okay.
Some aspect of our heartbeat
is
failing to signal to its peers that it has won. Dang, I think we should read this paper in full.
Yeah.
I think we've reached a local maximum. What do you think, Ben?
Definitely. I think we should look at some of the visualizations out there. So if we go to the site.
The course site?
The course site, yeah. So there's the extended Raft paper, but there's illustrated guide.
Okay.
We should look at the illustrated guide.
Okay.
Okay.
Okay. Okay. Okay.
Okay.
How do we come to consensus if we have multiple nodes? Okay, that's what we're trying to figure out.
Right.
A node can be in one of 3 states: the follower, candidate, or leader. Okay, we're not tracking the candidate state yet.
Yeah. So maybe we should do that. But
okay. All our nodes start in the follower state. If followers don't hear from a leader, then they can become a candidate. The candidate then requests votes from other nodes. Nodes will reply with their vote. The candidate becomes the leader if it gets votes from majority nodes. This process is called leader election. All changes to the system now go through the leader. Okay, that's just a visualization of a write to the leader. Each change is added as an entry in the node's log. This log entry is currently uncommitted, so it won't update the node's value. To commit the entry, the node first replicates to the following nodes. A leader waits until a majority of nodes have written the entry. The entry is now committed on the leader node, and the node state is 5. The leader then notifies the followers that the entry is committed, and the cluster has now come to consensus.
Okay.
Log replication. Cool. Okay. This is section 5.3. So there's these timeouts, 2 timeouts, which control the elections. One is the election timeout. The election timeout is the amount of time a follower waits until becoming a candidate.
Yep.
Okay. We should probably add or implement this as this part of the lab.
So an election timeout is the amount of time a candidate follower waits till becoming a candidate. Yeah. So we need some kind of an election timeout.
So it's randomized to be between 150 milliseconds and 300 milliseconds.
Okay.
So we can probably, even if we don't use this right now, we can probably add it.
Yep.
We actually started on this, the election timeout interval.
Yep.
We're trying to make it a constant, which is really loud. So it's between 150 milliseconds and 300 milliseconds. So 150 times time dot millisecond plus 150 times random dot random. Okay. Sorry?
Okay.
I don't know if we are using random, right? Filling random. Definitely not doing it right. Let's look at the playground. Okay. Between 0 and 1, a float between 0 and 1.
Okay.
And up 64. Okay. Let's add a print here, yeah?
Yep.
Node has election timeout. Okay. Okay.
Yeah.
We can actually, we don't need to make it an instance attribute.
I think we might.
Mismatch types, time.duration, and float 64.
Hmm.
You know how we might cast this to an integer?
No. Is it? Let's see if that works. Is that still complaining?
Yeah. Const initializer is not a constant.
Yeah, I think we should just make that part of the Raft.
That doesn't need to be a constant. Okay, we're getting closer. Same line, invalid operation, mismatch types, float, and duration.
Hmm.
So I think we need to cast the float to an int is probably what's going on. Yeah, we just this will round it down, I assume. Invalid operation. Ah.
Okay, let's see.
Really doesn't like multiplying integer by a so we do this with seconds down here when we sleep.
Yeah.
So how come Golang?
Let's look up how to. I sent a link.
Oh, in the chat?
Yeah.
Okay. Oops.
Yeah, so if we just do rands dot.
These are random integers, though.
Yeah,
oh, we can do 0, 150 is what you're suggesting?
Well, we could just do 150 to 300.
Oh, yeah, good point. Rather than trying to be smarty.
Yeah.
Okay. However, we may still get this this issue with integer times a millisecond variable or whatever the garbage.
Okay.
That'd be disappointing. 150 to 300. Yeah.
Yep.
Yeah. Mismatch types.
Mismatch.
Oh, God. How to multiply duration by integer? Good question. We need to convert the int to a time.duration. What the H?
Wait, no, this worked elsewhere. So, like, where
Yeah,
else
that's
are we
what blows my
using?
mind. Down here, where we call time.sleep, we are multiplying by a second as opposed to a millisecond.
Okay.
I don't know if that makes a difference. Let's just try casting this random int that's getting returned
Okay.
to a duration. Looks like it works. Okay, problem's still failing, but we can now see. It looks like all three of them have the same election timeout, though. Oh, ball sack.
I think it's because we're seeding with the time. Let's remove that.
Yeah, why do we even need to manually seed the random number generator?
Let's just comment that line out.
Okay, yeah, that looks better. Yeah, they're random now.
Okay.
Between 150 and 300 milliseconds. Man, the stuff we go through.
Yeah.
Just to get Go doing what we wanted to. I don't know if we need. Oh, let's leave that helper function there. We'll throw kudos out to the link that you shared.
Yeah.
Okay. We're continuing with the visualized raft.
Okay. Yep. So we have an election timeout.
We have an election timeout. It's between 150 milliseconds and 300 milliseconds. All right. All right. One of them becomes the candidate first.
Okay.
It increments the term, votes for itself. Are we voting for ourselves? I don't think we are. Well, we are sending ourselves a request to vote. Maybe we should not do that. We can say if we're about to send a vote to ourselves, let's instead add a vote. Be true.
Yeah. Okay.
And then continue. So we'll skip ourselves when sending out a request to vote.
Okay.
Make sense? Does that change anything about our tests? Huh? Looks like we're getting so far as sending out heartbeats and stuff. Cool.
Okay. And that's taking long because I think we added that sleep.
Yeah, at the end of append entries.
Yeah.
Okay, now we are voting for ourselves where we were not before. Sends out request vote RPCs, which we're doing.
Mm-hmm.
I don't know if it matters, but we're not doing it in parallel necessarily. We're doing it inside of a for loop.
Yeah.
But this is a non-blocking RPC, so it shouldn't matter. Okay. And so if upon receiving a send request vote, we should reset our election timeout.
Okay.
So election timeout is basically when was the last time we heard from the leader? Right?
Yep. Yep.
The last heard from any peer. So maybe we should create that.
Yep.
No, we were going to add it to the raft struct.
Yeah.
Is it last heard from any peer or any leader? Do you think?
I think it's last heard from any leader.
Okay.
Or last heard from leader, I guess.
Okay. We're going to add me.
Okay.
Is there a now method? Yeah. So this is an easy way to get at how much time has elapsed. So when we'll add to the send request vote, request vote RPC, we'll check so we'll see if this is greater than max timeout or something, then we will vote yes, I guess, or something like that.
I'm not sure.
Let's not do it yet.
I think where we need to use this is in the while loop.
Okay.
So in our make function, so we have kickoff election.
Mm-hmm.
So in the while loop, we should be like spinning here until the election until our timeout is passed. Does that make sense?
Yeah. So we're going to subtract, we're going to see how much time has elapsed since we last heard from the leader. Yeah.
Yeah.
And if that exceeds a max timeout, then we will kick off an election.
Yeah.
Although we don't have any max timeout specified yet. We're
yeah, election timeout interval.
Oh, yeah. Go. Okay. Shall I try running the test again? I mean, I don't expect a different output, but.
Yeah, maybe put that log message of starting the election.
Idea. The other thing I'm noticing, we're definitely goofing around with times again. We're running into time problems again. Ball sack. All right, maybe that's what they care about. Do not use time.now as type int in assignment. Seriously? Maybe it's because we're comparing it to an int. We don't define elapsed anywhere else. This is on line 325.
325?
Yeah, it's because we're saying it's an int here. And really, it's not an int, it's a timestamp.
Gotcha.
Or it's a time.time type. I think that was our problem.
Okay.
T.sub undefined on line 337. It is. That's capital S. Undefined votes on line 368.
Yeah.
We don't need to.
Yeah. We should. Yeah.
Maybe we should.
You should continue instead of. Yeah, there you go. Okay.
Okay. Cool. Okay. Tests are still failing. Everyone's voting for each other.
Okay. And now maybe we implement the
resetting our election timeout is something we're not doing.
Setting our election timeout?
Or resetting our election timeout when we receive.
Yeah, so let's try that.
So when we receive the request vote RPC.
We should do it in the receive the append entries RPC.
Well, we should probably do it in both, I would guess.
Well, because like request vote, just because someone's asked to vote doesn't mean they're the leader, right? We only know that someone's a leader when they send, or think they're a leader when they send a append entries RPC.
Okay.
Does that make sense?
Mm-hmm.
So here we just blindly update the timeout.
Right here?
Yeah.
Yeah, that sounds good to me.
Yeah.
That might prevent it won't interrupt a running election though.
It won't interrupt a running election. Yeah.
So if there's a different node that sends this node an append entry's heartbeat, notifying it that it's now the leader. It won an election. While we are resetting our timestamp, we won't prevent this node from completing its election and winning. I think you're right. I think this line is something we needed to add. Shall we continue with the visualization? Oh, our output looks different. Oh, well, no, both tests still fail. But
maybe let's get rid of that sleep that we added. Did you already remove that?
No, in the append entries?
Yeah.
I have not, no.
Okay. Maybe let's try now.
So it looks like everyone is trying to send each other append entries and everyone is winning their election.
Okay. Okay.
Okay. So we are resetting our election count. It's election timeout, excuse me.
Yep.
It says node singular. I wish we could go back. There's no back. What the? Oh my god! Now I just restarted. At least I can use the keyboard to press.
There's no back. That's funny.
Yeah. Okay. 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 This is all well tracked around. I hope I don't goof this up again.
You really can't press the back key?
No.
That's lame.
You can replay certain pages that have an animation, I think. Okay, we're back at leader election. The election timeout, okay. Okay, one of these guys wins. If the receiving node hasn't voted yet in this term, then it votes for the candidate. Okay, so we need, on a node basis, we need to keep track of our vote, which is something I don't think we're doing right now. Which is why, yeah, which is why our nodes are voting for multiple other nodes in the same term.
Okay.
So where we have this kicking off election, we don't say what term it's for. So if we add this log statement here, the details, I think we'll see that all three of the nodes are kicking off elections for the first term.
Yep.
And so they're all voting for each other like multiple times in the first term.
Yeah.
So we need to keep track of state somehow on the Raft instance just to keep track of who did we vote for in a given term. So besides current term, we need to keep track of current vote. The default will be ourselves, I guess. Okay. I mean, as soon as a vote's kicked off, the current term will be incremented, so our current vote won't matter. But in their send request vote or our request vote RPC,
yeah.
If args.term equals rf.current term.
Maybe we should add state for the like whether it's a candidate or a leader or a follower.
Okay.
Because you said you said initially in make we're going to vote for ourselves, but it said that's not the state that you start out in is follower, and maybe it'll just help us be more explicit. Like if we're like state here is follower, and then in our for loop, if we go into a candidate state, which we then kick off this process.
Well, nothing about this communication here in the visualization so far suggests that there's different behaviors if you're a candidate. Like none of these nodes are telling the other nodes that they're a candidate currently.
Yeah.
The reason for current vote, I was going to show in a sec, was that if we're getting a vote request for our current term, then we really just want to check whether the candidate is equal to our current vote. So, or if we have a current vote yet. So if the vote request is for our current term and we have a vote, which we should if our current term is equal, then we should, check current vote. If the current vote equals the candidate ID, then we're going to reply vote granted equals true. We're going to return there too. Yeah?
Okay, yeah.
So under these circumstances, we would send a vote granted equals true.
Okay.
The thing is, everyone is starting their current term or incrementing their current term. Where do we increment our here? Here's where we increment our current term.
Right.
So everyone is ending up on term 1.
Yep.
Let's see if this fixed everything. I'm curious.
I don't know. We don't have a problem with people voting true, though. We have a problem with people voting false.
None of them are voting false.
Yeah, our problem is that we don't get any false votes. So if we look at how the false is implemented there, or like how it's asking us to return false.
Yeah, these aren't being evaluated.
So like here, we're supposed to return false if the term is less than the current term. So, oh yeah, okay. That doesn't help us. What else does the paper say?
Voted for. We were writing current vote. I added a voted for or current vote attribute when we already have voted for.
Oh, okay.
So if voted for is null or voted for equals the candidate's ID and the last log index that we've got or that they've got is greater than or equal to the length of our logs, then vote true. So all the things I suggest we do here are redundant.
Right. Okay.
Let me get rid of all references to current vote since we now have voted for. Although I don't think we ever set voted for. I think that's, well, yeah, we don't set that anywhere. Yeah, that's probably our problem.
Yeah, so
we never record. We never record that.
Yeah.
Excuse me. Is this the only case in which we changed who we voted for?
Wait just a second. Yeah, I don't know. Like the figure just it describes the response, like the args and the reply that we should get to these functions, but it doesn't describe any internal state changes we should be making. I'm guessing voted for. Yeah, I mean we should if we return true, we should set our voted for to the candidate.
Yeah, agreed.
I'm guessing.
Yeah, this paper is not. I mean, it's probably genius and whatnot, but it's not like a how-to.
It's not a how-to. I'm sure it's like deep in the text somewhere. Like, oh, update the state.
I was going to suggest. Oh, so on line 161, we're going to overwrite our actual vote. So we're going to vote for the candidate. But do we need to like dereference the integer or some crazy ass stuff? Yeah, we do. Oh, cool. Now we're getting some falses. Cool. But both our tests are failing.
Okay, so wait, we got some.
So we're ending up with no leader.
Okay.
But 0 won the election, so why is there not the leader? How about we add another print statement here in the event that we get back our votes and we do not win the election. So we have if yes greater than no, won the election. We'll add else when somebody lost the election. Yeah.
Okay.
See whether the log output's any clearer. We here one won the election.
2 lost the election.
Wait, so 0 won the election, 0 is now the leader. Despite that,
Yeah.
the second node kicked off an election, won it, and is now a second leader.
Okay, interesting. So we got true. So everyone voted for 0 in the first election. And then in the second election, I'm guessing 0 voted false.
This is the third node.
Is it in order of nodes? Yeah, I guess it is.
Yeah. So the third node, having voted for the first node, did not say yes to the second node. Okay. However, the first node did say yes. It shouldn't have said yes because it had already voted for its term. I think we are, while we say we're voting for itself, we're not saying voted. We're not saying voted for equal to ourselves.
Okay.
I think that was the issue. We didn't vote for ourselves when kicking off our election process.
Right.
Ugh. Okay. Still, we're getting mixed results. Like one node gets all trues, another node gets 2 trues. And still, the test fails because it expected 1 leader, and none of them are a leader. What the H? Well, that might be a testing thing. How's the test? How's the test asserting that our we have a leader or not. Liquid leader. Get state. Have we looked at get state recently?
No.
We have this is leader method. It's supposed to return just is leader.
We
Weird.
added that.
Yeah, we did. We implemented this. Yeah. So what's the deal? None of our guys think they're leaders.
Is it because we don't think we're... Your code here, 2A. Are we setting is leader? Yeah.
Yeah.
I mean, I think that part is working, right? It is getting the state of all the nodes. It's just all the nodes think they're leaders.
But how come our tests are failing saying we have no leaders?
Oh.
Both our tests fail saying no leaders. We can modify the test to, well, not the test, but our get state method and print what we're seeing.
Okay.
Oh, what am I doing wrong here with the printf? Some of them are coming back true. Oh, one of our tests passed. Cool. It's only on the next test that we're seeing test failure. Yeah. So we've actually got one of our tests to pass.
Okay.
Cool.
So
in this case, 0 is becoming the leader. We keep checking the state of these other two. These other two, I don't know what the hell.
So it expected one leader but got none.
Yeah. So let's check this re-election test to see what it's doing.
Yep.
So we're passing this test, which is a very simple initial election to see whether only one leader gets elected. Re-election, I guess, kills off the first leader.
Yep.
And then it sees if the old leader rejoins, that shouldn't disturb the old leader. What?
Okay.
That's written poorly.
Oh wait, what's our Raft election timeout there?
Here?
Yeah.
1 second.
Yeah, I think we need to lower in our for loop. We're sleeping for 1 second.
Good idea.
We should lower it to, I don't know if there's a recommendation.
Let's say 200 milliseconds.
Yeah. Maybe that's it. I don't know.
That's a good point. Yeah. Yeah, I think that might solve our test. No, it looks like we had failure. Servers disagree on term. Okay, I think that's a different failure, though.
Wait, did our other test pass still?
Mm-hmm.
Okay.
Well, it's hard to see. Yeah, I don't know. Yeah, I'm having a hard time reading the Golang test output. How about you?
Yeah.
Damn, we had it working when it was 1 second.
Well, maybe try running it again. Maybe it's just like
flaky, yeah.
Flaky. I mean, we're using random timeouts, right?
So yeah, it looks like it failed again.
Okay.
What the H? Maybe it was the print statement. We had the print statement in get state.
Yeah.
What the F? Oh, it says passed. Was it really the print statement? Oh my god.
Let's try running it again. Try running.
Oh, all false. Interesting. Yeah. Oh yeah, it's a flaky one. Run again. This one looks like it passed. Yeah. All right. We got some flake going on.
Okay, so we have some flaky tests. It's, I think, variable on our timeouts, I'm sure.
Yeah. I just tried modifying the timeout. It's interesting. The error now says that servers disagree on term. So let's see what assertion is going on there real quick. That's on line 306 of config.go. So get state returns the current term, as well as whether they think they're leader or not. So what are we doing wrong with setting the term? We're probably just missing it in one spot, in one circumstance. So here we set the reply equal to the current term. We don't bump our term when voting for somebody, though.
Okay, that makes sense.
And we should probably write the reply term only after. So the important line here is line 163.
Yep.
Where we're, when voting, bumping our term.
Maybe.
Yeah. And if the term that's being requested of us is less than our current term, then we're saying, nope, already voted. This is the term that we were voting on now.
Yep.
So I might solve the first test. But not really. It still says servers disagree on term. We can add to that print statement we were adding in get state. We can print out what term they all think they are. Whoa, okay. So here is a good state. We seem to be kicking off the election when we don't need to be. And that might be because we are not resetting our own vote timeout when we're the leader.
Okay, interesting.
So because we're resetting the last heard from leader timestamp in the append entries,
yeah,
and we're skipping ourselves when we're sending the heartbeat.
Right. Well, actually, maybe we just need another break at the top or continue at the stop where it's like, if you're the leader, continue.
You don't need to vote for, you don't need to do a
You don't
vote.
need to kick off an election if you're the leader.
If RF is leader?
Yeah.
Or?
Yeah. I think that makes sense.
Yeah, sounds good. They're on different terms now, and the test still failed because. Okay. Well,
Okay.
we're coming up on 11, so I'm going to stop presenting for the second. But dude, this is hard.
This is hard. I think yeah. This is hard. What I think how this would play out like in practice is that the tests aren't really tests. They're just kind of like end-to-end acceptance tests. I think what would be more helpful is like this this method, the whatever one it is that we want to test, the get state or request vote RPC. Like if there was an actual test for that tested all the different edge cases or like the inputs and outputs that it would get, it'd be easier to understand what we're not doing or what we need to do. Does that make sense?
Yeah, I mean, we could write additional tests.
We could write additional tests, but I think
and the tests could do what you're suggesting they do, which is actually define what the expected behavior of stuff is, like get state or whatever.
Right.
Because yeah, none of the test cases that we've got are end-to-end tests. Yeah, that are.
I mean, because it should be like each of these RPCs, we should be able to write tests for them, and if all the tests pass, then hypothetically the system should work.
Yeah, I mean, we're also operating from the deficit of not having read the paper. So
right, also that, yeah.
Reading that paper was kind of helpful, although it's kind of out of line with the lab in that it kind of goes through everything linearly, but even that figure that the lab pointed us to looking at, it doesn't look like it has a complete list of the behaviors of the Raft system.
Right.
I don't know, man. I'm down to do a little bit more reading before next time for sure.
Yeah, let's try to do that.
All right, dude. Well, okay. It's been fun. We'll be back.
Good.
Cool. I'll take us offline.
All right.